Okay, good morning everyone. Today I'm going to explain datacamp's code, which is our university's workplace education's project which I have to do. So let's start. They are giving us our directions or what we have to do in this code. So basically what we have to do is this set of information. So I'm going to use Visual Studio because it's better. Sometimes the site gets stuck and all that stuff. So let's get started. So first thing what we have to do is import our libraries, which is, as you can see, these are our imported libraries. Pandas, which is a very powerful library, and numpy, sklearn model selection, and so on. These libraries are mainly machine learning libraries, which is used to learn the machine, to teach the machine how to, or the model how to deal with unknown data or new data and all that stuff. So the first thing we have to do is read the data using the pandas function read CSV. We read the data frames info, which is rental info. Our data frame is rental info here, and we save it into df rental, which is our which will be our mainly data set, our main data set. After that, we add information on the rental duration, which is rental length. For example, we create a column called rental length, and in order to get the rental length, what we have to do is use the function pandas, the function from pandas library, which is called toDateTime, which is a function that sets the date to today's date time. So basically what we're going to do is get our return date and rental date, which is, for example, this guy has took the DVD on 20th of the month and return it on the 25th of the month. So what we have to do is to get how many days did he took this DVD. What we have to do here is just subtract our return date from rental date and save it to rental length. So after that, what's going to happen is we got it in numbers, but did we get it in letters? For example, Monday, Tuesday. What are the days that this guy has took this DVD? What we're going to do in order to get this, we're going to create a column called length days or rental length days and save it into our dataset df rental. So in order to get that, we're going to use dt days, dt.days. It's a function of pandas, which is can get us the days in letters like Monday, Tuesday, and so on. So let's get into our next step of the code, which is the most important. So we start coding from here, okay? So let's have a look about our directions again, or our information. So firstly, we read the CSV file using the pandas and create a common rental date, and to get the how many days this customer had rented the DVD, how many days did he took it. So after that, we're going to create two columns dummy variables. Okay, so here they are giving special feature our functions that we have to use, which takes the value, which what the values it will going to take, and so on. So let us go back to our code and explain what happened here. So we created column called deleted scenes, which will contain our deleted scenes from the from the DVDs, or and save it into our dataset. Okay, we're going to use this function called where from numpy library, and then what's going to happen here, we're going to use the common special features and check if it contains, using the contains function str.contains any deleted scenes. If it contains any deleted scenes, the value will be set to 1. Okay, if it does not contain any deleted scenes, it will be automatically set to 0. which is this is our dummy variables, which will be temporarily save our data. So the next dummy, which is behind the scenes. First we created deleted scenes. After that we create a column called behind the scenes, which is from our instructions here, behind the scenes. Okay, we again use the mp.where function from numpy. Special features, we check if special features contains behind the scenes functions, if behind the scenes cuts. So if it contains that, the data the value will be set to 1. So that's it. And if if it does not contain any behind the scenes, it will automatically be set to 0. So this is our dummy variables, and what does it do? So after that, what we're going to do is drop the empty blocks in our table, or our let's say table. Okay, what we're going to do is special features and put all of our created function columns here into this calls to drop. Okay, we save it into this variable calls to drop, which we're going to drop later. So for example, what does it mean to have empty calls or something like that? Okay, let's check it here in using paint, which is will be the easiest way. So we have, for example, a table like this. Okay, and we have values and all that stuff in this table. For example, this is value. Okay, and this is value here, this is value, this is value, and this is value. And if we had if we don't drop these empty blocks, or the empty blocks in these functions, we will have, for example, empty sets here in our table. For example, this one will be empty, or this one will be set to 0, and we have a messed up data. So we're doing this in order to make our data more clean and more readable. After that, we go into a split feature, which is which will do to evaluate our model's performance. So we save this rental length days into y, okay, in order to deal with it later. And after that, we split it and use drop, which is after that I've already said we're going to drop it, but later. So it is come, and we save the dropped columns into x. Okay, we drop it df.rental, which is our dataset, dot drop, which is a function to drop the columns. And after that, what we have to say here is what are we going to drop. So what are we going to drop here is calls to drop, which is special features, rental length days, and also on. We set the access to 1, of course. So x train, x test, y train, y test, which is train test split. It is a function to create this function is mainly to teach the machine or the model how to deal with unknown sets of data or new sets of data. Okay, we set our x and y, which is x here is the dropped columns and y is the rental length days. Okay, we set the test size to 0.2 and the random state to 9. After all, the directions is given here. Okay, oh, by the way, we created this x. After that, we did this. Okay, after we doing drop the columns and dummy variables, we had to make a data frame x containing all the appropriate features, which is we already did, and choosing the interface as target y. So after we done all of that, and we organize our data set, what we have to do right now is to get into our main part, which is the processing, which we have started into splitting the data. Okay, so here our next direction is setting the random state to 9. Okay, let's go back to our Visual Studio. Now, after we have set and teach the machine how to deal with new or unknown sets of data. Okay, After that, we're going to use lasso. Lasso is it's a function of the library model selection. No, excuse me, sklearn linear model, which is machine learning libraries, which is used to increase the data's accuracy in predictions. So we set the alpha to 3 and the random state to 9. Okay, after that we're going to train the model. We created the model and gave it the data. Okay, so we have to access that data. We're going to use xtrain ytrain lasso.fit, which is our mainly the we saved our functions. We used lasso here and saved all of our stuff into lasso again, but it's a variable this time. So we use this variable or our getting values here. We fit it using the fit function into xtrain ytrain. Okay, so after that, after accessing the coefficients, what we have to do, our next step of instructions, recommend the model yielding a mean squared error less than 3 on the test. Okay, what does that means? The first thing we have to start with is getting the coefficients or the coefficients higher than 0 or the positive coefficients by all means. What we're going to do is save these positive coefficients into x lasso train and x lasso test, which is our main variables here. We're going to use the split functions eloc. Okay, xtrain.eloc. We take all of the, what does this means is we are going to take all of the array or all of the data set, and after that we get our condition ready, which is the coefficient that we set here, which is the data or the coefficients, is going to be higher than 0. We did the same for xtrain. Okay, we're going to do the same for xtest. After doing that and taking all the coefficients that higher than 0 or the positive ones, we're going to start our real job here. So the main part starts right now. What we're going to do is fit, predict, and get the mean squared error. Basically, it is for now, let's start from the first one, which is alls linear regression, which is an empty forest. Okay, or something like an array, we can say it's something like an array. After we do that, we do alls dot fit, which is we're going to fit this data x lasso train and x y train. Okay, we take this one, okay, and x y train. This is our main data here. Okay, here it is, and this is going to be our y train, which is going to be our predicted data or fitted data. We're going to fit it into y train. So y test predictions, we create a variable to predict the data of alls, which is this. We set the variable alls and fitted its data to x lasso fitted the data of x lasso train into y train. Okay, so we predict the data of our data set, or maybe the information that we're going to get into this machine into predict. Okay, using the x lasso test function. So we predict this function's data, and after that what we have to do is get the mean square error. What does that mean? What does our predicted data and the data that we're going to get, or the original data, what is the error percentage in between of them? What is the difference between of them? What is the difference in this data, our the original data and our predicted data? Okay, so our next step is creating a hyperparameter or the hyperparameters. They are functions, or let's say they are functions. Let's say they are functions, or let's say they are functions. It is mainly to deal with our forest, or the models and the data. It's mainly to organize its aspects, and to organize our data. We use the hyperparameters in a more to organize our data in a more efficient way. So Our first hyperparameter is param dist, which is a variable here, creating a variable, and we set our hyper parameter. The first thing is the estimators. We get its arrange. We use here function arrange from numpy library. We give it its variables. After that, we set the max depth, which is also a function. Which is also our variable. We set it to. It is mainly something like key value. This is our key, and this is our value here. And we set our key max depth into its value, which is we're going to use again the numpy function arrange. We give it its values. After that, we have to go into our next step, which is going to be um, to make our data more organized and make it more for example, let's say more understandable, let's say. So we create here an empty forest or an empty array, we can say, and save it into rf, our function random forest, shortage for random forest. So rand search, we create a variable here, and we use the function randomize search cv. It's the same here, which is from our machine learning libraries, random search cv. Okay, we set our data set, which is rf. The data are going to be saved into our forest here, random forest, and we set the param distributions into param distance. Okay, and we set the cv into 5 and random state to 9, which is have been given to us already. So after we set our data here in the randomize search cv function and save it into the random forest regressor function rf, okay, we have now to fit this data and predict and get the mean square of this data. Okay, first thing to do is take this variable, our the data's saved variable, okay, and fit it into x train and y train in order to be easier to deal with right now. So after that, we create a variable hyperparams. After fitting this, we create a variable hyperparams and get our rand research into best params, which means it will be filtered into our best parameters, okay, the best values. After that, we're going to get into our last part of the code, which is the easiest one, I guess. Our main job was here to fit the data, organize it, and predict the data, get the mean square errors, and fitting it. So our last step here is going to be choose the hyperparameters from the random forest, or filtering the data, let's say. So we going to use again the rf, our function, and call it into random forest regressor from the machine learning libraries up there, and then we get the n estimators. We set the n estimators to hyperparameters n estimators, which we set here already, which is here the range and the values. Our values are here, or maybe you can say the range, which is to be more accurate. We set our estimators, our hyperparams, to n estimators. We created this variable and put this column inside of this variable. After that, we're going to set the max depth, which we already set here in our parameters distance, and set the random state to 9, which is already given to us. After that, after we take the rf, after we give it all of the data, or give the data to the model, we're gonna have to fit it, predict all of these data, and mean square the value, mean square errors, which is the difference between our original and predicted data. So we're going to fit the x train into y train and predict this data, x test, which is our original data. And after all of this, we have to get the mean squared error, y test, and rf predictions. So the y test here is our fitted data from x train, and after that we have to predict it. The predicted data, RF predict, we're going to use it here, our predicted data from RF, okay, in order to get from between the difference of the predicted data and the original data. We have to use the function mean squared error, which is a function from our machine learning libraries, scalar matrix. It's a mathematical library. So our last part of the code is get the lowest MSI, or the best MSI is the lowest, which means the lower you get the mean squared error, which means the better the machine or the model has been doing its job. So after that, it's our last part of the code. We set the best model, which is a variable we created, into RF. After doing all of these changes to RF, getting fitting, predicting data, setting the estimators and the max depth, random state, all of that stuff, we're going to save it as best model. And after that, we're going to MSI random forest. We set it into best MSI, which is our variable here, which is the lowest of the squared error, the lowest difference. And that's all for this code. So that's all. It was an easy one actually. It's very understandable, no hard functions and all of that. So thank you for watching.